Okay, this is an example of a uniform probability distribution problem. This is problem 3 in the chapter 6 assignment. So we've got a property bid where the seller's saying any bid in excess of $10,200 will be accepted. We look at the competitors and we don't think anybody's going to bid more than $15,000. And we're saying that the probability of winning is evenly distributed across this range. So first we want to know the probability that $12,000 will win. Next we want to know what's the probability that $14,000 will win. Then we're asked to maximize the probability of winning. And then we're asked to determine if we should bid 13,100 or should we bid whatever the answer was in part C in order to maximize the probability that we will win. And lastly, they want to know what the expected profit is for this bid, whichever one we select, 13,100 or whatever the answer is in part C. So I'm going to work through these and show you how to solve them. Most people are having problems with this final answer here, expected profit, and I'll show you why you're having problems with it. So really the whole point of the uniform probability distribution is to introduce the idea that the probability is the area under the curve for whatever the probability distribution happens to be. And they think this uniform probability distribution is the best way to demonstrate that problem. So they tell you that, again, because it's nice and neat rectangular, we all know how to calculate the area of a rectangle. It is the width times the height. And they tell you that the height is going to be the maximum value minus or 1 over the maximum value minus the minimum value. It's that ratio. So in the first case, the probability that 12,000 will win is the 12,000 minus the minimum, which is the length of that rectangle, divided by the 15,000 minus 10,200, which is the height, or 1 over the height, 1 over that ratio. 1,800 over 4,800 gives you 0.375. Rounded to 2 decimal places, 0.38. For 14,000, same thing. It's simply this larger rectangle here that goes from 14,000 to 10,200 multiplied by the same ratio, 1 over the 15,000 minus 10,200, 3,800 over 4,800, 0.791, rounded to 2 decimal places, 0.79. So now they ask, what's the probability of maximizing, or what is the bid that will maximize the probability that you win? Well, obviously, you bid whatever you think the maximum bid is going to be. Left my zeros out there. So that maximum bid would be at 15,000, where the probability of winning is 1, because that would be 15,000 minus 10,200 divided by 15,000 minus 10,200. 1 over 1, that would maximize the probability that you win. Next, they tell you that somebody's interested in paying $16,000 for this property. And we assume that the current seller doesn't know that. Otherwise, why would they sell it to you? They just sell it to that person themselves. But the expected profit is the revenue minus the bid, whatever you decide to bid, times the probability that that bid's going to win. So if we look at 15,000, we've got 16,000 minus 15,000, or 1,000 times 1. That's an expected profit of $100. Your friend told you should bid 13,100. If we do 16,000 minus 13,100 times the probability at 13,100, which is again 13,100 minus 10,200 divided by or multiplied by 1 over 15,000 minus 10,200, that probability comes out to be 0.6041 multiplied by the 2,900, which is the difference between your bid and 16,000, gives you an answer of 17,751.89. And some of you, if you got this far, probably typed that in and had the computer tell you it was wrong. Well, here's the reason why. The person who programmed this particular problem decided that they wanted you to round the probability to 2 decimal places. They didn't tell you that, but that's what they expected you to do. That's not your fault. If you multiply the 2,900 by 0.60, you get 1,740. And that is the answer that the computer will mark as being correct. So placing these answers in, disregard these check marks, you'll see when I check my work, all these answers are marked correct. So if you got this one wrong, you probably failed to use a rounded probability to get this answer of 1740. I don't consider that to be a bad thing because throughout this book, the author's been telling you use 4 significant digits whenever you calculate a probability. But in this particular problem, they somehow expect you to round that probability to 2 decimal places in order to calculate the answer. So, hope this helps.